Hi guys, my name is Mark. I'm studying engineering at Trinity College Dublin, and we're going to tackle question 4 from the higher level Physics 2020 paper. This question is on the topic of resistivity and is an experimental question. That means it's worth a total of 40 marks. And yeah, let's get started. In question 4, we are asked about a length of wire L, and we are asked various questions based on the resistivity of this wire. Here we are also given this table down below. We are told the length of the wire and the resistance measured at that length, and as well as this we are also told the diameter of the wire in millimeters. This is a fairly standard resistivity question. Just a few things to note here. This length is in centimeters, and as well as this the diameter of the wire is measured in millimeters, so just make sure you're using centimeters, or should I say meters, when you're converting, because that's an SI unit. We need to use meters. And yeah, let's get started straight into the question. In part I, we are asked to name several pieces of apparatus that we used throughout the experiment to measure different parts of it. In this case, we were asked to measure the diameter, the length, and the resistance of the wire. These are just straightforward theory questions, and the answers go as followed. To measure the diameter of the wire, you're going to use a micrometer or a Vernier calipers. Either of these answers are completely acceptable. You don't have to have both of them written down to get the full marks. For part B, you're asked how to measure the length. Simple way to do this is using a meter stick. And finally, part C, how to measure the resistance of the wire. Most people would say to use a digital multimeter or just a multimeter. Another answer you could have here is a ohmmeter, just that comes to the top of my mind now. Either of these are acceptable answers. You don't have to have both of them written down to get full marks. This question was worth a total of 9 marks, and you got 3 marks for getting each of these A, B, and C correct. So 3 marks for writing down a micrometer or Vernier caliper, 3 marks for writing down a meter stick, and 3 marks for writing down a multimeter or an ohmmeter. Either or are completely acceptable. In part 2, we were asked, how did the student ensure that the diameter of the wire was uniform? Yet again, similar to part 1, this is just a straightforward theory question, and the answer goes as follows. You want to measure the diameter of the wire when there is no kinks in it. Basically, before you measure it, just straighten out the wire as flat as possible. Kind of ensures that the diameter is uniform along the whole thing. Nice, quick and simple. And the breakdown for the marks goes as follows. You got 3 marks for mentioning that there were no kinks in the wire. That was the buzzword here. And this section, nice and simple, because it was only a one-liner. It was worth a total of 3 marks. In part 3, you were asked to use the data given to draw a graph of or against L. What that basically means is we want to draw or our resistance versus L, and L here being our length. Now, the nice thing to note here is that at the start of our question, we are given the table. So going back here to our table at the start of the question, it's given to us. Just a few things to note. As I said earlier, we have to convert this into meters. So just a little arrow here saying change this into meters. Another thing you're going to want to do here is convert this into meters as well, just so you don't get confused. But for all intents and purposes, very little has to be done to this data set in order to get the full marks. So yeah, these are just a few key things to keep in mind when you're drawing our graph. Going back to our question, now that we have looked at our table and made sure that we've converted our length into meters instead of centimeters, we can now begin to plot our graph of our resistance versus our length. And here we have our graph. Now, on the y-axis, I have plotted our resistance here. And an interesting thing to know here is that you must include the unit. So in this case, we have included the unit for resistance, our ohms. On our x-axis, we also have our length. If I scroll down here, so our length here. And I have converted the table from above into meters. Simple SI unit change, just divide by 100 to convert all of our centimeters to meters. As always, we're working with SI units. And scrolling back up here, we have a look at our table. What I've simply done is I have plotted the resistance on the y and the respective length on our x. Yet again, making sure that the distances here are uniform and easy to understand and very well labeled. We have a tile on the graph as well up here. And each of the points are measured, or should I say plotted in this purpley kind of plum color. And our line of best fit, which is also incredibly important in this question as well, is the purple line. Now, the point of the line of best fit, which is just this line here, just in case you're not following me, this line here is drawn so that it goes through as many points, or as close to as many points as possible. And in this case, we also see that it goes through the origin here at the bottom. This question was worth a total of 9 marks, and the breakdown goes as follows. You got 3 marks for correctly labeling your axes. That basically means giving a title to them and including your unit of measurement. So in this case, the ohms for resistance and meter for length. As well as this, you got 3 marks for having your points plotted. So 3 marks. Important thing to know here is that you have 1, 2, 3, 4, 5, and 6. So there's 6 points you need to plot. Make sure that you've plotted all of them. Use all of the data given to you in the question. And you got your final 3 marks for drawing a line of good fit. So as we said here, this dark purple line going through or as close to as many of the points as possible. And in this case, it goes through our origin as well. This is our line of best fit. So yeah, this is where you got your final 3 points, adding all together to give you a total of 9. In part IV, we were asked to calculate the slope of the graph. And in this case, every time I see the word slope in a question like this, my head goes straight to the slope formula and kind of coordinate geometry. So if you cannot remember the slope formula off by heart, and even if you're just a little bit unsure, always go straight to your log table. It's better safe than sorry in these types of situations because it's just easier than losing marks. So yeah, straight to the log tables. Here we're asked to find the slope, so here we have our slope formula, and it goes as follows. M is equal to y2 minus y1, all divided by x2 minus x1. And what I take away from this is that we need 2 points in order to calculate our slope. We need a x1, y1, and an x2, y2. So what that means is when we go back to our graph, we're going to have to take out 2 points along our line of best fit to find the overall slope. So here on the left, we have our graph of resistance versus length. I'm just going to write down our formula. So it's going to be M, our slope, is going to equal to y2 minus y1 all divided by x2 minus x1. And that's our formula for our slope. And what that basically means, as I was saying earlier, is we need 2 points in order to find the slope. And always a quick one in this instance is the origin. And the reason that's a quick one is because it's 0, 0, and we can see that the graph, or the line of best fit in this case, passes through the origin. So it's a nice quick point. So I'll just write that down. So our first point is going to be, so point 1 is going to equal to 0, 0. And that's just our 0, 0, our origin. Now, finding point 2 can be a wee bit more tricky. What I recommend is always finding a point that is kind of on your graph paper, kind of meets where 2 boxes kind of come together. So it's a little bit easier to kind of make an approximation of where it is. So in this case, I'm going to pick a point in and around, I'll pick this point here. And the reason I'm going to pick this point here is because if I take a dotted line down, yet again, highly recommend you take these dotted lines down and across, because it's just a bit, yet again, easier for you to visualize what your what the point is. We can easily, figure out what our x and our y coordinate is. So what we're going to find out is that this point here, so we're going to call it is point 2, is going to be on our x, our length axis. We're going to have it's slightly more than halfway between 0.5 and 0.7. So we're going to say it's around 0.62. And for our y, we're going to say it's roughly halfway between 0.2 and 0.25, so this would be 0.22. And there are 2 points that we can sub. Another thing I'll say is that if you make substitution errors quite often like I did, I highly recommend that you just label the points out. So in this case, for point 1, we're going to have our x1 and our y1, and for our point 2, we're going to have our x2 and our y2, and this kind of shows the examiner that you understand what's being asked of you and what you're doing. And if you make a little accident, maybe subbing in x1 instead of x2 or something like that, the examiner knows that you kind of know what's going on. You just made a simple error like that. So now rewriting out our formula, we have m, or our slope, is going to be y2, which we said was 0.225, minus y1, which was 0, all divided now by x2, which we said was 0.62, minus 0, which was our x1. And all we have to do now is put this into our calculator and get a value for our slope. And plugging this into our calculator, we're going to get a value for a slope of in and around 0.36 in this case. Now, obviously, just a quick thing to mention here is that the slope may vary slightly, and as long as you get anything in and around 0.34, you should be fine. Reason it varies is because you might pick slightly different line of best fit, or you might pick different points. You might get slightly different answers based on your approximations, but that doesn't really matter as long as you get in and around 0.34, a little above, a little under, even a little bit of wiggle room, so it should be fine either. This question was worth, or should I say this part of the question was worth a total of 6 marks, and it was broken down as follows. You got 2 marks if you wrote down the formula that for the slope, so in this case the one we found in our log tables, you got another 2 marks for correctly substituting this into the formula. So down here we have another 2 marks for correctly putting in our points, and you got a final 2 marks for, or should I say it'll be, you get your 2 marks for your eventual answer. So in this case we got 0.36, but as I said, anything in and around 0.34 should be fine. In part 5 we are asked to hence calculate the resistivity of the material, and you know, whenever I see the word hence here at the start, I kind of, you have to, what that kind of means is you want to use information that you found earlier on to solve this question. And obviously sometimes you might be able to do it without it, and that's great if you can, but in this case we're going to use information that we found earlier to help solve the problem. So what we're asked here to do is calculate the resistivity. Now if you don't know what the resistivity is, it's a material that depends, or should I say it's a property that depends on the material. So it only changes depending on what material you're looking at. For example, the resistivity of copper is different to the resistivity of iron. And in this case, there's, as always, a formula that you want to use. And if you can't remember that formula, yet again, you're just going straight to your log tables to find it. So in the electricity section of your log tables, here we find the formula for resistivity. So in this case, it is rho, or resistivity, denoted by the Greek letter rho. And this is equal to RA divided by L. So resistance times area divided by L. So writing down our formula that we found in the log tables, what we said was rho, or our resistivity, is going to equal to R times A all divided by L. And you might be kind of wondering now, where does the hence come into it? Where does, you know, the information that we found earlier? And the information that we found earlier is actually our slope of the graph. Now, you might be wondering, where does that come from? How is that useful to hear? But if we look at kind of what the graph was asking us for, we were looking for resistance versus our length. And this is, you know, you can rewrite this as R divided by L, and that's kind of just like looking at the resistance divided by L, or R versus L. And what we did is, by finding the slope, we found that R divided by L was 0.36. Now you might get something slightly different, a little high, a little low. As long as we were saying earlier, anything in around 0.34 is fine. Now in this case, if we actually look at our formula here, we can actually bring this down and kind of break it up. So if I bring this down here, what we're going to have is rho is going to equal to R over L times A, and all I've just really done is written out the fraction slightly different. And the reason I've done that is just to kind of show you how what we know, this R divided by L, is actually in this formula. And if we multiply this by the area, we can actually find the resistivity. Now the question is, what is the area actually? And you know, if you don't know what the area is asking for in this question, I'll kind of, to explain a little bit better, over on the right here I've got a little diagram of our wire. So if this is our wire, kind of cut along its length, or along its face, should I say, this area here, kind of marked out with this cross hatching, is our cross-sectional area, and that's the area that we're looking for. So if you were to cut a wire and like look along its face, you'll see that the shape that we have left is a circle, and the formula for finding the area of a circle is going to equal to pi r squared. So if we were to rewrite this whole thing, we'd be able to say that rho, or our resistivity, is going to equal to 0.36 times pi times r squared, where r squared is going to be the radius of our wire that we are testing. Now if we go back to the start of our question at the top, what we know is we're actually told the diameter of the wire is 2.055 millimeters. So we know that the diameter is 2.055 millimeters. What we need to do is find the radius. So the way that we find the radius is by dividing our diameter in half. So it's going to be 2.05 divided by 2 millimeters. Now, yet again, important thing to do here is convert from millimeters to meters, because we always want to work in SI units. So what we're going to do is we're going to convert that into meters. So it's going to be 2.05 millimeters divided by 2. And now we're going to also divide by 10 to convert it into centimeters, and then divided by a further 100 to convert it into meters. So all I've done here is kind of generally written it out. If you plug this into your calculator, you're going to get a value. So actually we'll find that now. By plugging this into your calculator, you'll find that the value we get is 0.001025 meters. So it's a very, very small length, because obviously it's the diameter, or should I say the radius of a wire. And what we're going to use is we're going to use this number now to find the cross-sectional area and therefore find our resistivity. So scrolling down a bit, as I was saying earlier, our area is going to equal to pi times r. Now we already said r was 0.001025, and what we're going to do is square that in order to find our area. So when you plug this into your calculator, you'll find that the value we're given is 3.3 by 10 to the minus 6. Now you're going to have a lot of decimal places there and a few numbers further back, but they're fairly insignificant in terms of the accuracy of this answer. But if you want to be super precise, obviously you can work with the expanded out form. So now going back to the question, we were asked to find our resistivity. So as we were saying earlier, our resistivity is going to equal to 0.36 times our area. We said our area is now 3.3 by 10 to the minus 6. And all we have to do now is yet again sub this into our calculator, and we'll get hopefully our answer for our resistivity. When we sub this into our calculator, we're going to get an answer of 1.18 by 10 to the minus 6. And this is going to be our resistivity. It's measured in ohm meters. And just to kind of explain to you, you obviously might have a slightly different answer here, and that's completely fine. The reason you might get a slightly different answer here is because, as I said earlier, we use different slopes. We all found maybe slightly differing slopes. As long as around 0.34 it was fine. And because we're using that kind of number or evaluation we had for our slope, you might get a slightly different answer here for our resistivity. But as long as it is anything in and around 1.12 by 10 to the minus 6, you should be fine. So in this case, we should be grand. This question had a total of 6 marks going for it, and you got 3 marks for simply writing down our formula. Resistivity is equal to RA divided by L, and you got your final 3 marks for getting your answer here at the end. Anything in and around that 1.12 by 10 to the minus 6 ohm meters was perfectly acceptable. So if you got a little bit high, a little bit low, doesn't really matter, all's well. And yeah. In part VI, we were asked, how would the resistance of a fixed length of wire change if its diameter doubled? So this is kind of a more theoretical question, and it kind of, you have to work a little bit more closely with the formulas that you're given. But we're just going to take it step by step, and hopefully it'll make a little bit more sense. In a question like this, I always write down the formulas that I'm working with. So in this case, we're asked for resistance, and we're given length. So in this in this case, I'd always write down the formula rho is going to equal to RA divided by L. So this is our formula yet again for finding resistance. Another thing to note here is that we are told the diameter, and we're asked kind of specifically about the diameter. And this formula that we have here already isn't one that's going to work with the diameter, because it's working with resistance, an area, and a length. So the diameter isn't kind of explicitly mentioned there. But what you do notice is that we're working with area, and in order to find kind of the area or the cross-sectional area in this case, you need to use the formula pi or squared. And this kind of comes a little bit closer to what we're looking for, because we're told about the diameter, and now we have a formula that works with the radius. So radius and the diameter are related, so we're getting a step closer. Just one thing to note here, if you wanted to rewrite this formula again and being a little bit more kind of targeted to what we're given in the question, you might say A is equal to pi times diameter over 2, all to be squared. So I'm just rewriting the radius, should I say, as diameter over 2. That's another thing I will mention. In this case, we're using 2 R's. We're using a capital R for resistance and a lowercase r for radius. Try not to get them mixed up. It can be really easy to kind of get things mixed up in that case, so just kind of be careful with that. But going back to this area formula, what we have now is rewritten it in terms of diameter. And if you want to even simplify this a little bit further, what you're going to have is pi times d squared all over 4. So all I'm doing there is squaring out the d over 2, and we get d squared over 4. So now we have 2 formulas that kind of work with this question, and now we can kind of go on towards kind of what the question is actually asking us. It's saying that we have a we have a wire of fixed length, and we're asked what happens if the resistance, what would happen to the resistance if we doubled the diameter. So an important thing to note here is that the length is constant, and another thing that is constant is the resistivity. So in this question, we are asked specifically about resistance. So I'm going to rearrange our formula up here to focus specifically on our resistance. So I'm going to rearrange it so we have R on its own. So if we rearrange it to have R on its own, we're going to have R is going to equal to rho times L and then divided by A. And this is just so that we have resistance on one side and everything else on the other. And now what we can actually do again is we can sub in this formula that we have up here for our A. So what we're going to have is rho times L, yeah, divided by A. And A in this case is going to be, I'll just write down over here, pi times d squared over 4. And I should just put it in brackets just to make sure you don't kind of get mixed up with the kind of the double fraction there. I know I did when I was doing this. And rearranging this even again, we can bring the 4 above, so we'll get 4 times rho times L all divided by pi d squared. And that's now a completely general formula for the resistance of a wire given its resistivity, length, and its diameter. So nice, very very useful formula kind of that we just built ourselves, and we can now actually use this to solve our question. What we know already is that the resistivity of this material is constant. The reason it's constant is because we're not changing the material when we're measuring the wire. It's always going to stay the same material. Another thing that we know as up in the question is that this fixed length up here, and that means that the length doesn't change. So if we look actually just at the top half of this equation, 4 times rho times L. 4 is a constant number. The resistivity of the material doesn't change. The length doesn't change. So the top half of this equation isn't actually going to change at all. Another thing to know here is actually on the bottom half we have this pi, and pi is just a number as well. It's not going to change at all, which means that the only thing that's really changing here is this d squared. And that all that means is that the resistance of this wire is directly proportional to 1 over d squared. And the reason that we have that 1 over d squared is because d squared is on the denominator of the fraction. And this is kind of the essential kind of thing that you want to realize when you're doing this question, is that the resistance is proportional to 1 over d squared. And by using this relationship, we can actually solve this question. So going back to the question, we're asked what would happen if the diameter was doubled. So all I'm going to do here is sub in 2 for diameter and see what happens. So if I say resistance is proportional to 1 over 2 squared, that's going to be the same as saying resistance is proportional to 1 over 4. All that means is what's happening is the resistance is changing by a factor of 4, and it is getting smaller. So if I just write that down, so it's 4 times smaller, and you're getting the smaller here in this case by 1 over 4. It's getting a quarter as big, if that makes sense, which is the same as getting 4 times smaller. And yeah, this is kind of the solution at the end of it. And it was a bit of a tricky question because it's expecting you to be able to work with all the information given. But if you kind of break it down piece by piece, what we'll notice here is that the resistance it'll get 4 times smaller if we double the diameter. So this question was worth a total of 7 marks, and the breakdown goes as follows. There was 2 marks going here for writing down your formula, having your resistivity, having your area, and also this formula actually over here, eventually figuring out that the resistance was directly proportional to 1 over d squared. This is where you got your first 2 marks, and you got 2 marks also for saying that it gets 4 times smaller, and you got 4 times just changing by a factor of 4, and you got 3 marks for saying that it gets smaller. So that that smaller is coming from the fact that it's 1 over 4 and not multiplied by just 4 on its own, because that means it'd be getting 4 times bigger. So that's where that smaller is coming from. But yeah, this was a pretty tricky one, I'd admit. There's a lot more going on than you might expect, but there's a lot of these types of questions, and if you kind of get used to doing one, they all kind of are slightly similar, so it's not too bad.